Hi everyone, it's Mr. Barbier back with another video. So in today's video, we are going to learn about the last three properties of exponents, and they are collectively called the power rules. Okay, so let's get right into it. The first power rule is called the power to power rule. Okay, and as it says here, this rule states that when a base's exponent is raised to another exponent, simply keep the base the same and multiply the exponents. So let's get this straight. Basically, what we've been doing so far with the exponent rules is we know that when we multiply by the same base, we keep the base the same and add the exponents, right? And we know that when we divide by the same base, we keep the base the same and subtract the exponents. Now what we're doing, notice, is that we have a base. In this case, it's a variable base, x. It's raised to the power of 3. Okay, let me zoom in on that a little bit. All right, and it's in parentheses, and there's another exponent outside the parentheses. Okay, so notice in this situation, the base only appears once, unlike the product rule and the quotient rule where you see, two bases. You see that you're looking for matching bases, basically. You're looking for an x and an x, or a y and a y. But in this case, the base only appears one time, and it's raised to a power, but it's in parentheses, and you see another exponent outside those parentheses, okay? So what do we do in this situation? We use what's called the power to power rule, which again states that when a base's exponent is raised to another exponent, okay? The base's exponent is 3, okay? But it's raised to another exponent, which is outside the parentheses, and there's the exponent 2. What do? We simply keep the base the same as we always do and multiply the exponents. For example, as you can see here, x to the third power, in parentheses, raised to the second power, equals x to the 3 times 2. Okay, not 3 plus 2, not 3 minus 2, like we've done in the past. 3 times 2. We're now multiplying, ladies and gentlemen. We are multiplying. 3 times 2, which of course is 6. We keep the base x, and it's x to the 6th power. Now, a couple things I want to say about that. First of all, I want to show you something, and I want you to see that we can actually do this another way. So, for example, let me write it right here. Imagine I say to you, okay, the problem was x to the third, right? So let me write it down. X to the third power, and it's in parentheses raised to the second. Okay? It's always good to know more than one way to do a math problem. So I want to show you something very, very, very simple. If I said to you, okay, how do you evaluate 5 to the second power, also known as 5 squared? You would know exactly what to do. You would tell me, Mr. Barbier, that's easy. It's 5 times 5. Right? Well, if that's the case, this is no different, okay? We are still raising something to the second power. What are we raising? We're not raising 5. We're raising what's inside the parentheses, everything inside the parentheses, x to the third power. So basically, we do the exact same thing we did up here. We take this entire expression and we write it twice. Okay, so as you can see, this is the same thing as this. We took the base, which is raised to the second power. We multiply it by itself twice. Here we're taking the base, which is raised to the second power, In this case, the base is everything inside these parentheses. We wrote it 2 times. Now, hold on a minute. Doesn't this look familiar? This is the product rule, right? These 2 things are multiplied by each other. So what do? We know what to do. We keep the base and we add the exponents, which is what the product rule says. And look what happens. Keep the base the same. 3 plus 3, 6. Same exact answer. Okay? So it's good to know how to do any math problem in more than one way. All right? Especially when you're not sure if your answer is right, you could use another method to check to see if your answer is right. So all I did was I just took this expression, because it's raised to the 2nd power, I wrote it twice, and I followed the product rule, which says if the basis is the same, keep the base the same and add the exponents. Okay, and you can do that with any problem that looks just like this or very similar to it. You're going to see later that we can apply this method to other problems. Okay, let's get back to this. So, as you can see, the example is done for you, and you will do these 3 problems for classwork, okay? What I'd like you to do, though, is if the problem is like a simple problem like this where the exponent is just 2, you could use the method I just showed you. But what I'd like you to do for this, for this exercise is to practice this method specifically so that you have practice in it. Remember, this lesson is learning the power rule, okay? So even though you know how to do the product rule, let's concentrate on practicing the skills for the power rule, which says multiply the outside exponent by the inside. One thing I will say, though, really quick, is this also looks very similar to the distributive property. So, in other words, we can take this outside exponent, watch me very carefully, I'm going to circle it, I'm going to draw an arrow going inside. We know that when you see an outside number, right, we draw an arrow from the outside to the inside. Now, I know you're used to seeing this distribution when the number is on the left, right, going from left to right. So the difference here is that these are exponents, and the exponent is always put on the upper right-hand side, right? And one more thing I want to point out, always multiply exponent by exponent. Never exponent by base. Okay, it's very important. Exponent times exponent. 2 times 3 gives me that x to the 6th power. And you can do all of these the same exact way, okay? You can literally just do 1, 2, and 3 the same way. Circle the outside exponent, arrow to the inside exponent, multiply, and keep the base the same. For this one, and this one. Do me a favor, though, for all 3 of these, if you have a negative exponent, I'd like you to convert that negative exponent into a positive exponent by using the reciprocal, like you already learned in the previous videos. Okay, we will practice that a little bit later. All right, so these 3 are yours. Okay, let's take a look at the power of product rule. Okay, the power of product rule states, let's take a look. This rule states that an exponent outside parentheses can be distributed. This rule states that an exponent outside parentheses, can be distributed to the exponent of every base of a multiplication expression inside parentheses, including coefficients. All right, what does that mean? Basically, it means exactly what we did above, except now, take a look, we have more than one base inside the parentheses. It's the only difference, ladies and gentlemen, only difference, okay? So notice that we have an exponent outside, but we have 1, 2, 3 bases inside. Now you might say, Mr. Barbier, why is this different? Why is it given a different name? Why is it called power of product rule? Because these bases inside the parentheses because there's more than one base and they're all touching each other, we know that represents multiplication, right? So what's happening is inside the parentheses, we have multiplication being represented. X is touching Y, which is touching Z. And because they're all touching, that represents multiplication, right? But the power of product rule states that when you have an exponent on the outside of a multiplication expression inside the parentheses, you can distribute that outside exponent to all of the exponents inside of the parentheses. All right? That's what this is saying. So let's take a look at this example. We have x squared, y to the negative first, and z to the positive third. The exponent 5 on the outside is going to be distributed, so to speak, to all three exponents inside. It's going to be multiplied by all three exponents inside. So 5 times 3, actually, let's go from left to right. 5 times 2 gives you x to the 10th. 5 times negative 1 gives me y to the negative 5th. And 5 times 3 gives me z to the positive 15th. Again, remember, we are multiplying the exponents now, not adding or subtracting. Okay? So here's my answer, but as you all know, I hope you remember from our previous video on the negative exponent property, that we can take this and do what to it? Let me see if someone knows. Okay, I think I heard someone say, Mr. Barbier, you can put the whole thing over the number 1. You are correct. And then do what to it? Okay, someone just said, well, because x has a positive exponent of 10, I leave it on top. You are correct. And because y has a negative exponent, y to the negative 5, I want to make that negative 5 a positive 5. What do I do? Okay, very good. We drop it to the bottom. Remember my rhyme, when you cross the line, you change the sign. Okay? Make sure to write that 5 small. Don't write it big. Remember, it's an exponent. Exponents should remain small and in the upper right-hand corner. Z to the 15th. The 15 is positive. It's a positive exponent, which means the z stays where? Very good. On top. And there's my answer. X to the 10th power, z to the 15th power over y to the positive 5th power, because we dropped it from the top of the line to the bottom of the line. There it is. Okay, ladies and gentlemen, there it is. Now, you will do these 3 problems yourself, okay, for classwork. 1, 2, 3. All right? And let's look at one more exponent rule, the final exponent rule, the final member of the power rules family. And it's right here. Okay, give me 1 second. It's called the power of quotient rule. All right, now, the power of quotient rule states that an exponent outside parentheses can be distributed to the exponent of every base of a division expression inside the parentheses, including coefficients. Folks, this is no different than what we just did. The only difference is that now, instead of inside the parentheses seeing a multiplication expression, inside the parentheses, we see a division expression. That fraction bar represents division. But nothing changes. Basically, we still take the exponent on the outside. We still multiply by the exponent's top and bottom of the fraction, okay? We still multiply that exponent on the outside by the exponent in the numerator and exponent in the denominator. Okay, so what is 3 times 2? 6, so it's x to the 6th power, and 3 times 5, 15, so it's going to be y to the 15th power. You keep the base the same. Okay, and there we have it. All right. One thing, the final answer does not need to remain in parentheses, so you can ignore the parentheses here. All right, so the final answer is just x to the 6th over y to the 15th. Now, again, you will do for classwork these 3 problems. Actually 4. 1, 2, 3, and 4. Now some of you are saying, Mr. Barbier, wait a minute, but I'm still learning this and I still don't have it down. Guess what? Don't worry. We have some practice problems right here. All right? So, ladies and gentlemen, I hope you have your notebooks out. Okay, please have your notebook out. Please have your writing utensil in your hand. You learn math by doing. You don't learn math by watching. Okay, so do with me, please. Do math with me. Don't have me do it by myself. You must do to learn. You don't watch to learn. And that goes with anything in life, not just math. Okay, let's get right to it. So, power to power rule. You write this problem down, you pause the video, and you give me the answer right now. Go for it. Okay, look back. If you need to rewind the tape and look back and see how do you do this again. Maybe you forgot. Okay, go for it. Okay, I'm going to assume that we all did the problem, and let's see if we're right. So, x to the 8th power raised to the 3rd power. Someone talk to me right now. I can hear you through the video. Don't worry. Okay, someone just said, Mr. Barbier, I keep the base the same. Okay, and we're going to multiply the outside exponent by the inside exponent. And we're going to get what? Okay, someone said x to the 11th power. Does everybody agree with that? X to the 11th power? Okay, someone just said, no, Mr. Barbier. 8 plus 3 is 11. We're not adding, we are multiplying. The answer is actually what? Oh, okay, x to the 24th power? You are correct. Ladies and gentlemen, common mistake is students think that, we're still doing the product rule. We're still adding the exponents here. No, okay, we're doing the power to power rule right now. All right, remember, exponent outside parentheses multiplies by the exponent inside. Practice and you won't forget, okay? Make sure you practice. Let's continue. Here's another problem. Ladies and gentlemen, try it yourself, okay? Right now, pause the video, go for it. Okay, I'm gonna assume that you're ready. All right, if you've unpaused the video, let's take a look at what you did. What did you do? Tell me. Okay, someone just said, Mr. B, I'm going to multiply the outside exponent 4 by the inside exponent -3, and I'm going to keep the base the same. Very good. Let's do it. So the base is a. I keep it the same. And someone tell me 4 times -3 is what? Okay, someone just said, Mr. Barbier, it's -12. Very good. All right, now wait a minute. I have a negative exponent. All right, I want to simplify it further. What do? Okay, someone said, Mr. Barbier, you're going to put this over 1 so that we can flip it, right, to its reciprocal. Okay, good. So we put it over 1, and now let's flip it. And what does it become? It becomes 1 over what? Okay, a to the, to the what power? Make sure you get the exponent right. A to what power? Okay, someone just said +12, Mr. Barbier, because once you flip it, the exponent becomes a positive, right? Very good. This is the final answer. Okay, very good. So far we're doing great. Okay, another problem. Ready? This time I'm going to ask you to evaluate. So ladies and gentlemen, let's try this problem over here. This time we are evaluating, which means I want you to solve this until you get a final number, final answer. Pause the video, go for it. All right, you've unpaused. Let's do it now. Someone just said, Mr. Barbier, we're going to multiply the -1 by the +2. Very good. All right. And what do we get? Someone just said we get 6 to the -2 power, right? Because -1 times 2, -1 times, right? Times 2 is a -2. So, question, is my answer -12? Because 6 times -2 is -12. Okay, someone just said no. Is my answer -36? Because 6 squared is 36 and I make the answer negative. Okay, wait, some of you are probably not sure. You're like, I think so. Wait a minute, ladies and gentlemen. Wait a minute. Let's not forget what we did with this previous problem over here. We have a negative exponent. We want to make the negative exponent a positive exponent, right? How do we do that? Nothing changes in math. Nothing changes. We still put it over what? Over 1, right? And then what else are we going to do? We are going to flip it, right? We're going to flip it to make the exponent positive. So now it becomes 1 over what? 6 to the, someone say it for me before I say it. Okay, good. +2, because once you flip it, the exponent becomes positive, right? Once you flip this to its reciprocal, it becomes positive. And now, wait a minute. Unlike the previous problem, I can actually solve the bottom, right? Because my base now is a number. It's not a variable. So let's continue. Let's finish this problem. And the final answer is what, somebody? Okay, someone just said, well, Mr. Barbier, I'm not sure I'm going to write it out. I'm going to write it out and get 6 times 6. Very good. And then 6, we could do it right here. 6 times 6 is what? Because when in doubt, we should always write it out. Okay, 36. Very good. So now my answer is 1 over 36. Final question. Does this give me a whole number, 36? Is that my final answer, 36? Someone just said no. Good. It's not 36. It stays a fraction because 36 over 1 is 36, not 1 over 36. Please be careful. Don't make that mistake. Okay? 1 over 36 stays a fraction, 1 over 36. If it was 36 over 1, that would be 36. All right. Very good. Now, ladies and gentlemen, that was our practice of power to power rule. Let's now take a look at power of product rule. Okay, power of product rule. Let's look back if you need to remind yourself what to do, but I don't think you do. I think most of you know exactly what to do. Okay, the only difference between this and what we just did up here is that now we have more than one variable base inside the parentheses. Okay, but the process is the same. Nothing changes. We still take that outside exponent and do what? Okay, very good. We distribute it to all 3 exponents inside the parentheses. Very good. So let's do it. Okay. We're going to keep the x the same, right? Let's start with x. So let's go from left to right, ladies and gentlemen. 2 exponent 2 times exponent 3 gives me x to the what? Okay, someone just said x to the 6th power. Very good. Exponent 2 times -2 exponent gives me what? Okay, someone just said, Mr. Barbier, it's going to be y to the what? -4th? Is that right? Okay, very good. And we have one more variable base, z, right? And 2 times 4 gives me z to the, very good, ladies and gentlemen, z to the 8th. Now, once again, I see a negative exponent. I'd like you to give me an answer without a negative exponent. What do? We put the whole thing over 1. And then in my final answer, what stays on top and what drops to the bottom? Okay, someone just said, Mr. Barbier, well, I know the x to the 6th stays on top because the 6 is positive. That exponent is positive. Very good. All right. And what else is going to happen? Okay, the y has an exponent of -4. So I'm going to draw a fraction bar and drop that y to the bottom and make the 4 positive, because when you cross the line, you change the sign. Very good. And the z to the 8th will stay on top. There it is. Okay, very, very, very good. Let's keep it moving. And folks, you're going to see, we're going to do a few more problems where we can actually do that part, this step faster as far as making the negative exponents positive. We can do it all in one step. You'll see as we continue. Let's look at number 2, okay, of the power of product rule. Okay, stay with me. All right, here we go. Now we have this problem here. Ladies and gentlemen, something tells me you guys are getting the flow of this. Pause the video, go for it. All right, I hope you've tried it, you've unpaused, and now it's time to look at your answer. So once again, outside exponent multiplies by inside exponents. And now that we're getting the flow, let's pick up the pace just a little bit to see, to get to some other practice problems, okay? So we have, what do we have here? We have let me readjust, sorry. We have a to the what power? Someone tell me. Don't forget, what's a negative times a negative? Negative times a negative is very good. Someone just said positive what? 12, very good. All right. And then we have the variable base b. b, -3 times +2 is, someone tell me. Very good, -6. And what else? We have the base c. And -3 times -3 is what? Someone remember, a negative times a negative, don't get it wrong, is a +9. Very good. Now, let's continue doing what we did before, and let's draw that fraction bar and put the 1 underneath just to start, okay? And now give me that final answer. What stays on top and what drops to the bottom of the fraction bar? Okay, someone just said, Mr. Barbier, a to the 12th stays on top because the exponent 12 is positive. Correct. What about the b? Very good. Someone just said, Mr. Barbier, drop the b to the bottom because the 6 exponent 6 is a negative and we want to make it positive. So we drop it to the bottom, we cross the line, and we change the sign to a +6. Very good. The c, what happens? Someone just said, Mr. Barbier, it stays on the top because the exponent is positive. And there's my answer. Very good. Okay, ladies and gentlemen, here's a third problem. Do it by yourself. Try it. Now, this one's a little bit trickier, so, because we have a coefficient now. I say, Mr. B, wait a minute, we have a coefficient. What do we do? Well, if you're not sure, I'll show you right now. But if you want to try it yourself, you can try it. Okay, let's get right into it. Ladies and gentlemen, first of all, I want to say something before we start. Do you see anything in the parentheses that doesn't have an exponent? Okay, you might say, Mr. Barbier, wait, y doesn't have an exponent? You're right. So guess what? We're going to give it an exponent, 1. Okay, so let me be very clear about something. Up until now, we haven't had a situation in which we had a base without an exponent. Now we do have that situation. What do you do when that happens? We put an invisible 1. Now, you might think, okay, I'm done. Time to distribute. Be careful. Check this out. This coefficient, the number 2, even though it's not a variable base, it still has an exponent and it's still considered a base. Okay? It's a number, but it still has a base. I call it a numerical base. So this is a numerical base, therefore it has an exponent. Just like the y has an exponent of 1, this 2 also has an exponent of 1. That is very often forgotten about, and that is the common mistake in this topic. Students forget that coefficients also are bases, and therefore they also have exponents. Invisible positive 1. And now I take this exponent -2 and I distribute it to all of the exponents inside, including the invisible exponents. Okay, that's the part to remember, ladies and gentlemen. Coefficients also have exponents. You must put them. Okay, you must put them or else your answer will be incorrect. Okay, let's now continue. So I'm going to put here equals. I'm going to put here 2, which is the coefficient, 2, all right? And now -2 times +1 is -2, correct? So it's 2 to the -2 power, all right? And now I have x, okay? -2 times -2. The exponent -2 gives me what, someone? Someone just said a +4. Very good. Okay. Don't forget our next variable base, which is y. -2 times +1 is what? Someone just said -2. Very good. And we have finally z. And someone tell me -2 times -3 is, okay, someone just said +6 because the signs are the same. They're both negative. All right, now, ladies and gentlemen, let's continue. Put the entire thing over 1 like we've done all along. And we want to change, we want to change those negative exponents to positive. How? Just like this. You already know how, don't you? The 2 to the -2, where does it go? Bottom, yes? And that exponent becomes +2. Now, let me see something very quickly. Some of you might say, Mr. Barbier, doesn't 2x drop to the bottom because the x and the 2 are together? No. Okay, I want to be very clear about that. 2, the coefficient, has a negative exponent, but x has a positive exponent, which means that the coefficient drops to the bottom, but the x, because x's exponent is positive, it stays on top. Very important. Okay, very important. I know that might look weird to some of you, but that's the way it is, all right? Even though 2, I call variable terms married couples, but even though a married couple may be one unit, but they're still 2 individual people, right? So 2 is dropping down, x stays up. What about the y? Someone tell me. Okay, someone just said, Mr. Barbier, y drops down also because the exponent is negative. You are right. And once I drop it, it becomes a positive. And what about the z? The z, very good, stays on top. Now, folks, one more thing we can do with this problem. We can evaluate it further. Okay, we can simplify it further. You might say, Mr. Barbier, why? Because, ladies and gentlemen, we have a base that's a number, 2 to the second power. I can solve that. I can evaluate that. What is 2 to the second power? Okay, someone just said 4. Very good. Keep that 4 on the bottom because that's where the 2 to the second power is. It's on the bottom. Now you might say, what about everything else? Stays exactly the same. And one more thing I want to remind you. I cannot evaluate an exponent expression until I make it positive first, right? So you might say, Mr. Barbier, why couldn't you have solved it right here? Because the 2 exponent 2 was negative. You cannot evaluate an exponent expression until you make the exponent from negative to positive. Once you do that, now you can evaluate it. Okay, it's very, very, very important for you to understand. Okay, ladies and gentlemen, we have one final thing here, and that is the power of quotient rule, which is the same thing as everything else, except now inside the parentheses is a division expression instead of a multiplication expression. That's the only difference. Okay, only difference. So, ladies and gentlemen, look at this expression. You tell me, do you see a base without an exponent? Okay, someone just said, yes, Mr. Barbier, there's a y there with no exponent. What do? You know what we do. We put an invisible what? 1. That is correct. Okay? And now we distribute this exponent to every exponent inside the parentheses, top and, look at this, guys, and bottom. Okay, let's do it. So someone tell me right now, pause the video if you think you got this, pause it and do it. Okay, someone just told me, Mr. Barbier, it's going to be x to the 8th power on top. Very good. And on the bottom, someone say it. Y to the what? 2nd, okay, also known as y squared. And z to the what? Someone just said 6th power. Very, very good. Ladies and gentlemen, that's the answer. Okay, that's the answer. Very simple, very easy. Let's move on. If you think you got this, ladies and gentlemen, you do it. And don't get scared because you see the negative exponent. Challenge yourself, okay? Pause the video, go for it. Okay, let's see what you got. Let's see what you got. First things first, ladies and gentlemen, make this a habit. Make this a habit, please. Look for bases without exponents first and put that invisible 1. So tell me right now, where do I need to put an invisible 1? Someone just said, Mr. B, A is missing an exponent. I'm going to put a 1 right here. Good. Someone else just said, Mr. B, D is missing an exponent. I'm going to put a 1 right here. Good. Now let's distribute. Okay? Don't distribute until you have those invisible ones put in place first. Okay? Please, please, please do that for me. All right. And don't forget, we're distributing to every exponent inside. Every exponent, top and bottom, right? We are multiplying. Don't forget, multiplying, not adding, not subtracting. Okay. If you still didn't pause the video, pause it now and see what you're going to get. You can do this, okay? Trust yourself. Okay. I hope you've tried it and you've unpaused. Let's go. Someone tell me. It's going to be on top what? A to the what? Okay, someone just said -3 times 1 is -3. Very good. And then what else? B to the what? Okay, someone just said -3 times -2 is a +6 because a negative times a negative is a positive. What about the bottom? Okay, someone just said, Mr. Barbier, it's going to be C to the negative 9, right? Don't forget, 3 times 3 is 9, not 6. If you put 6, please correct that. And it's going to be a negative, correct? Because it's a negative times a positive. And what about D? D is going to be D to the what? Okay, good, negative 3. Now, let's see if you remember how to do this part, ladies and gentlemen. We have negative exponents, top and bottom. What do I do here? Folks, you know I like to make math easy. Okay, let me just keep it very simple for you. If you see a negative, you want to move it and make it positive. If it's positive already, you want to leave it where it is. Okay, it's that simple. So you see a negative exponent, cross the line, change the sign. So let's start with, let's go in alphabetical order. You see an A on top, right? Is the exponent negative or positive? Someone just said it's negative, so what I'm going to do, very simple. Cross the line, change the sign. Drop it to the what? Bottom. Very good. Positive. Go alphabetical order. See the B? What exponent is that? Positive or negative? Someone said positive, so are we going to drop it to the bottom? No, we're not. It stays on top because the exponent is positive. All right? Let's go with the C. What sign is that? Okay, someone just said it's a negative. So cross the line, meaning move it up now from bottom to top and make it what? Positive. You're right. Okay, let me make this 6 look a little bit better. And then finally, D. What happens to the D? It's negative on the bottom, right? So we want to make that exponent positive. So we do what? We bring it to the top. Let me make the line a little bit longer. It's going to be D to the 3rd power. Okay. Now you might say, Mr. Barbie, looks a little weird. I didn't know until now that the A was going to be the only variable base in the bottom. So ideally, this would be in the middle, right? But this is our answer. Okay. This is it. Just slide the A to the 3rd to the middle. So that looks a little bit better. Okay, folks, we have one last problem and we're done. Here it is. Again, ladies and gentlemen, challenge yourself. Don't get scared. Pause the video right now. Go for it. Okay, I'm going to assume you've unpaused, that you've tried your best, that you've given this your best effort, and you want to see if your answer is right. Or even if you tried it and you got stuck along the way, but you tried it. I'm still proud of you for trying. Let's do it now. First things first. Do you see any bases without exponents? And when I say any bases, I don't mean just the variables. You know that, right? I mean variables or coefficients. Okay, someone just said, Mr. Barbier, x is missing an exponent. I'm going to put a 1. Is that the only exponent that's missing? Look carefully, everybody. Okay, someone just said, Mr. Barbier, 5 is a coefficient, but it's also a base. Therefore, it has an invisible 1 as an exponent. 4 is a coefficient, but it's also a base, so it's missing an invisible 1 exponent. Correct. Now we can distribute to all of the exponents. Now, I'm using the term distribute just so that, this topic is made easier for you. But just know that mathematically speaking, strictly mathematically speaking, this is not really called the distributive property, but I'm calling it that just to make it easier for you to remember because you're familiar with the distributive property. All right? Okay, so we are going to multiply as always. Someone help me break this down. Let's go. Bring it home for us. Bring it home. Okay, draw that fraction bar. So at the top, we're going to have what? 5 to the what? Someone just said -2. Very good. And then x to the what? -2 again. And then y to the what? Okay, very good. -10. What about the bottom? 4 to the -2. I hope you have that. Very good. And then z to the what? Okay, remember, negative times a negative. Positive, good, what? 12. Okay, let's keep it moving, okay? We're not done yet. Let's keep it moving. We have negative exponents that we want to convert to positive exponents. So let's do that. We have 5 on top. Where does it need to go? Because it's a negative exponent. It's to drop to the bottom and become a positive exponent. Okay, let's do the 4 right now. 4 is on the bottom. It has a negative exponent. What should we do? Move it to the top and make it a what? Positive exponent. All right? Remember, folks, these two only switched because both had negative exponents. I want to be very clear about that. Okay? If they didn't, if say 4 had a positive exponent of 2, it wouldn't move to the top. It would stay on the bottom. And because it's touching the 5, right, they would be touching each other. You would be solving the exponents first and then multiplying them. That's how you would do that. Okay, x to the negative 2. Let's go in alphabetical order. X to the negative second power. What happens? Someone just said drops to the bottom and becomes a positive. Y comes next. What should I do with it? Very good. Drop it to the bottom and it becomes a positive 10 because the exponent was negative on top. Z, I'm going to say I'm going to bring it to the top because the 4 is all alone by itself. Is that right? Someone just said no, Mr. B. It actually stays in the bottom. Why does it stay on the bottom? Because the exponent is a positive 12. And you only move it if the exponent is negative. You are correct. It stays here. And notice what I'm doing. Notice how my answer is in standard form. X, Y, Z, alphabetical. But folks, we're not done yet, right? We're not done yet because we want to evaluate the coefficients. Someone help me right now. 4 squared is what times what? Very good. 4 times 4, which is, okay, thank you, 16. 5 squared is what times what? Okay, 5 times 5, which is 25. Very good. And then what about the variables? They just what? Stay the same. Ladies and gentlemen, there it is. There's the final answer. And you did great, okay? You all did great. So here's the deal, okay? Here's the deal. Now that you are masters of this, and you are, okay, believe that, you are masters of this. You are now going to do the classwork, all right, by yourself. You're going to do a great job with that. I know you are, okay? You're going to do the classwork by yourself. Let me remind you, it looks just like this, okay? You're going to do these 3 problems by yourself. You're going to do these 3 problems by yourself. And you're going to do these 4 problems, okay? 1, 2, 3, 4 by yourself, all right? And that's all I'm going to assign for now is classwork. We're going to continue with extra work in the next video, part 2 of this video, which will include more complex problems, all right? But for now, we're going to stop there. Ladies and gentlemen, you're going to do great. Continue practicing, and you're going to be masters of math, and you already are a master of math. I just want you to know that, okay? I want you to know that that's exactly what you are. Keep practicing, keep practicing. You're going to get this. And ladies and gentlemen, I'll see you in the next video. All right, part 2 of this video. Take care.